So let's look at a couple of example questions. First, let's start with this example question where we're going to be talking about shirts, and they come in three different colors, sizes, and they also come in two different available colors. So the shirts come in size small, medium, and large, and they also come in colors red and blue. And we're going to be interested in how many different combinations of sizes and colors can we have of these shirts. So you can have a small blue one, you can have a large red one. Exactly how many of these combinations can we get? So one way that we could try solving this problem is to start off with a tree, what we call a tree. So first, we're going to deal with the three different sizes of shirts. So they can come in small, medium, or large. And for each small, medium, and large, they can also come in red or blue. So red, blue, red, blue, red, blue. Now we can denote each combination. So we got a small red shirt, a small blue shirt, we have a medium red shirt, a medium blue shirt, and a large red shirt, and a large blue shirt. So we have exhausted all the combinations of small, medium, larges, and red and blue for our option. Now we can just count up how many we have. 1, 2, 3, 4, 5, 6. So 6 combinations. Well, we can also figure this out by saying the number of combinations equals the number of options we have for our first option times the number of options we have for our second. So because there's small, medium, large, we have 3 sizes times 2 colors equals 6 combinations. And we can see how we can expand this. So we had 2 options in this example. We can really have n number of options. And we would just multiply all available combinations between all of them. All right, so let's move on to another example where if we have a 3-letter code containing that's using 8 available letters, how many different combinations with different restrictions to this 3-letter code using 8 possible letters? So what happens if no letters are allowed to repeat in our code? So that would mean for the very first, we're still going to solve this using n1 times n2 times n3 will equal the number of combinations. All right, so let's deal with the first n. How many letters are available for our first n? We're going to have 8 letters available for our first n. And because no letters are allowed to repeat, the letter that was chosen for our first letter can't be used for the second letter. So we remove one of the letters from the 8. How many combinations or how many available numbers do we have for our second number? Well, that would just be 1 less than 8. Similarly, if 2 letters have been removed from our set, how many available options do we have for our third number? Would just be 6. So 8 times 7 times 6 will give us 336 combinations. All right, what if letters are able to repeat in our question? So once again, we're going to do n1 times n2 times n3. But if letters are allowed to repeat, we're going to have 8 letters available for our first n. We're going to have 8 letters again available for our second n. And we're going to have 8 letters available for our third n. So 8 times 8 times 8 is 512 number of combinations that for 3-letter codes when all 8 letters are allowed to be used for each available code spot. So what about if adjacent letters cannot repeat? Once again, we're still going to use N1 times N2 times N3 to figure out for the first letter, there's still going to be 8 letters available. But if adjacent letters are able to repeat, then we know whatever was chosen for the first N is no longer going to be available for our second N. So that means we are going to have 7 options available for our second N. Similarly, whatever what was our for N2 is not going to be able to be available for N3. So that means we are going to have 7 options available for our N3 one as well. So 8 times 7 times 7 is going to be 392 combinations.